Number 5 and 6 are our rate problems. We're still using conversion factors, but now we're starting out with 75 miles per 1 hour. So we have a unit down on the bottom. This is one of those problems where I would go ahead and identify what I want to finish with. I don't know how I'm going to get there, but I know I need to finish with feet per second. I'm looking at this problem right now. I'm not looking at it. I want feet per second as my final goal. I don't know how I'm going to get there, but this helps me go ahead and say when I know I'm done with one half the problem or not. Let's tackle the miles first. They're on top. To tackle miles, I can go directly from miles to feet because I look up at my conversion chart and I see miles to feet is a direct conversion. 5,280 feet is 1 mile. I let the units tell me where to put them. 1 mile has to go on the bottom because I want those to cancel out. And then we have 5,280 feet up in the numerator. Okay? Well, if I'm checking my units as I go, feet is what I want to end with, and I've got it. So I'm done messing with the distance units. All I've got now is I've got to mess with the time units. I have hours right now, and I want to go to seconds. Some of you know exactly how many seconds are an hour. That's fine if you do. You can do this in one step. But most of us just think of hours to minutes. That's not in our conversion chart because it's just something that you should actually know, so we don't put it on there. 1 hour has to be 60 minutes. So now I've actually got some numbers appearing in the bottom. I have to account for that at the end. But I'm just letting the units do the talking. Hours cancel with hours. What I have now is minutes in the bottom, and that's really close to seconds. Only one more step to get my final answer. 1 minute is 60 seconds. Minutes cancel with minutes. I'm just looking at the units. I've got seconds in the bottom, and I already had feet in the top. I didn't change that. So I've got the right thing going. Now it's just a calculator problem. This one requires a little bit extra work though. If I multiply straight across the top, I've got 75 times 5,280, and that equals 396,000. It's a big number, okay? 396,000. On the bottom, I've got 1 times 1 times 60 times 60. Well, that boils down to basically just 60 times 60, which is 3,600. You do not leave your answer like this. You have to actually simplify it, okay? You have to simplify that answer. To do that, it's just a division problem. 396,000 divided by 3,600 gives us 110. So our final answer is 110 feet per second. I should have those units here as well. Okay, 110 feet per second should be my answer. It's a long problem, a lot went on there. Now, alternatively, your calculators that do fractions, you can type in all 4, 1, 2, 3, 4 of these as fractions, just as the numbers, not the units, just the numbers. And when you press enter, it will spit out this answer of 110. It'll save you this step in the middle, okay? If you're really good with the fraction keys on the calculator, you can type in these big fractions and multiply them all together. Number 6 is also a conversion problem that is a rate. Okay, so now we're not looking at 5. I'm going to just mark through it. We're looking at 6. I'm going to need the room, so I'm starting over here on the far left. We've got 4,224 ounces, or OZ, per hour. And we want to take this into kilograms per day. Okay, so that's an English measurement. That's a measurement we use into a kilogram, which is something we don't use often. That's a metric measurement. So somewhere along the way, I know to get to my final answer of kilograms per day, I've got to have to go from English to metric. So to do that, I need my conversion chart. To go from hours to days, I know those because they're just time. But ounces to kilograms. So I look up here and I say, okay, I'm going ounces to kilograms, and I don't know how to do that. I'm looking through. I see ounces right here, but it takes me to pounds. That's not what we want, but it's a piece of the puzzle. Because right above it, you can see that pounds will take us to kilograms. So it's 2 steps to get to kilograms, okay? That first step was that 16 ounces is 1 pound. I'll abbreviate pound with LB, okay? So that's a 1 pound. I'm just letting the units do the talking. The ounces canceled out. I'm at pounds right now. Well, that's good because I can go from pounds to kilograms with that other conversion. 1 kilogram is 2.2 pounds. So 1 kilogram is 2.2 pounds. I'm letting the units do the talking, and I've got kilograms up top, and that's what I want in my finished product, kilograms and kilograms. So I'm done messing with the top units, okay? Now I've got to go from hours to days. Well, to do that, I know that one day has 24 hours. That's just a known fact. Let the units do the talking. They cancel, and I see that I've got days down in the bottom, and that's what I wanted to finish with. So once my units are done, that means the problem is done, and it's just a calculator thing from here. We've got 4,224 ounces times 1 times 1 times 24, which is just times 24. We get that big ugly number, 101,376. What's down on the bottom is 16 times 2.2, which is 35.2. Okay, so some big ugly numbers, but that's okay. Because from here, it's just a calculator division problem. 101,376 divided by 35.2 tells us that we've got 2,880 kilograms per day. 2,880 kilograms per day. And that's my final answer there. Okay, so those take a lot of work. It's a lot of work to do those rate problems.